Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapkot. Dear students, in the previous class we discussed what is convection heat transfer, what is radiation heat transfer and what is conduction heat transfer. In the last class we discussed combined modes of heat transfer. Okay, and also we discussed some numericals on combined modes of heat transfer. Dear students, we understood the definition of conduction heat transfer, radiation heat transfer and convection heat transfer. Okay, so come now onwards we will try to study in detail about first mode of heat transfer, that is conduction heat transfer. Okay, so in detail we are going to study conduction heat transfer, and also we are going to derive some equations which are related to conduction heat transfer, and also we are going to solve some numericals which are related to conduction heat transfer. Dear students, we'll move towards next topic, that is conduction heat transfer. Dear students, in the previous class we discussed what is conduction heat transfer. Conduction heat transfer is a mode of heat transfer in which heat is going to transfer from one part of the substance to another part of the substance, or one part of the system to another part of the system, where the molecules or atoms are at rest, but they may vibrate, but they will not alter. If the heat takes place in that fashion, the type of heat transfer we are going to call it as a conduction heat transfer. Dear students, you can see here now this experiment. So with aluminum rod and attached with iron nails held with wax, that I explained in detail, right? So here what will happen, dear students, now you are supplying heat at one end, the heat is going to move from this end to this end because of these atoms or molecules, but the molecules will be at rest, but they will transfer heat from one molecule to another molecule, like that. Continuously what will happen, heat is going to transfer from high temperature region to low temperature region. Okay, if heat reaches this point, right, then what will happen, this nail is going to fall down. That means what we can experience, the heat is transferred to this particular point. If heat is transferred to this point, that means what, again this nail is going to fall down. That means what, heat is transferred from this to this. If the heat is transferring from one end to another in a solid material where the molecules are at rest, if the heat transfer takes place in that fashion, that type of heat transfer we are going to call it as a conduction heat transfer, dear students. Okay, then conduction heat transfer. In conduction heat transfer what happens, the atoms or molecules, they will vibrate, and they will vibrate, but they will not alter their position. Okay, and they are going to transfer the energy, that is heat energy. That heat energy is going to propagate from high temperature region to low temperature region, dear students. Okay, now conduction heat transfer mechanism. Dear students, what happens, mechanism, the process of heat transfer through direct contact and molecular collision. The heat is going to transfer because of molecules collision and contact of molecules each other. If the heat transfer takes place in that fashion, that is the heat conduction. Then conduction heat transfer is going to happen in solids, that too especially in metals. Okay, because of their effective free electrons in the metals. So conduction heat transfer is going to take better in material, in metals. Okay, because of their free electrons. And conduction heat transfer is going to depend on some important factors. What are those some important factors that we can see here now, dear students? Thermal conductivity of the material, temperature difference, area and thickness all play an important role in the conduction heat transfer, dear students. We have seen a number of examples for conduction heat transfer in our day-to-day life, dear students. When cooking, right, when you are going to put a metal spoon into the hot pot, right, then what happens, over a period of time you are going to experience some amount of heat in the metal spoon. That means what, conduction heat transfer. Like that we can get a number of application or examples for conduction heat transfer, dear students. Yes, how the conduction heat transfer is going to take place? The conduction heat transfer is going to take place because of molecular collision or molecular interaction or physical contact. So energy is going to transfer, that is heat energy is going to transfer. That type of heat transfer we are going to call it as a conduction heat transfer. When it comes to conduction heat transfer, that is represented as Q. When it comes to conduction heat transfer, right, some important factors they are going to affect on the conduction heat transfer. Those are thermal conductivity, area, temperature and thickness. With the help of these all factors, one of the well-known scientists, that is French mathematician Joseph Fourier, has given an equation, or he has given a law towards the conduction heat transfer. Then that law popularly we are calling it as a Fourier's law of conduction. Fourier's law of conduction. That equation we already know, dear students. That is minus k into dt by dx. Here you can see thermal conductivity, area, temperature difference, thickness all play a very important role in the rate of heat transfer, that too in conduction, dear students. Okay, fine. Yes, quick recall. What are the important factors we need to consider in heat conduction or conduction heat transfer? Temperature difference. If the temperature difference is more, then heat transfer will be more. Then if there is a more particle interaction, then more conduction heat transfer will happen. Then material contact. The heat transfer which is going to take place because of material contact, that is known to be conduction heat transfer, dear students. Okay, fine. Now, just a minute. So now, this I already explained. The heat transfer is going to take place from one part to another part because of molecular interaction or physical contact. If the heat is going to take place from high temperature region to low temperature region, that is known to be conduction heat transfer, dear students. Okay, so I have attached 3 nails here now. The 3 nails, one by one they are going to fall down once the heat reaches. If the heat transfer in the solid material or aluminum rod, the type of heat transfer we are going to call it as a conduction heat transfer, dear students. Then when conduction heat transfer, right, that is conduction heat transfer is represented as a Q. So what I will do, dear students, I will take a metal plate. I will try to supply certain amount of heat to the metal plate, dear students. Then what will happen now in this direction? When you are going to transfer heat to the metal plate, right, there is an area of the metal plate. That area of the metal plate play a very important role in the conduction heat transfer. One thing. And thermal conductivity. The thermal conductivity is nothing but it's a property of material to conduct the heat. So that thermal conductivity of material also play a very important role in the conduction heat transfer, dear students. If thickness, the thickness also play a very important role. That's also affect the radiation conduction heat transfer. That is Tx. Then, dear students, I will supply heat at one end. So heat supplied, I will represent it as a point 1. Heat is going to reject or it is going to transfer at point 2. That is, I will mark here T2. Sorry, point 2. The temperature at point 1 I will mark here as a T1. Temperature at point 2 I will mark it as a T2. If the heat transfer taking place in a metal, right, metal plate, that I can express in terms of a thermal circuit. That means what? That you can see here now, dear student. Here is the high temperature region. The heat is going to transfer in this fashion. When heat is transferring in a metal, right, there is some resistance to the flow of heat. That resistance is represented as a R actually. Okay, then end of the temperature I will mark it here as a T2. The same I can express in terms of thermal circuit here now. So initial temperature I will mark here as a T1. When the heat is flowing across the metal plate, right, so that heat I will represent it as a Q. When heat is flowing in a metal plate, right, definitely there is some resistance. That resistance is represented as a R, whereas R is nothing but L divided by K into A. Then final temperature I will mark here as a T2. Then you have inlet, T1 temperature, T2 temperature, then you have resistance. With the help of this, what I can do, I can calculate the conduction rate of heat transfer, that is Q is equal to minus K into dt by dx, dear students. Then experimentation of that conduction heat transfer, what I have told, right, aluminum rod with nails attached with wax. That experiment you can see here now. Conduction is the transfer of heat energy through a material by direct contact of particles. Then you can see here now, dear students. So we are going to supply amount of heat to the aluminum rod at one end. Heat will slowly, it is going to transfer in the aluminum rod from high temperature region to low temperature region. Once the heat reaches to this point, right, then what happens now? The wax is going to fall down. The wax nail attached with wax is going to fall down. Hence, we can say that conduction heat transfer takes place in the aluminum rod. Yes, heat is getting transferred, dear students. You can observe. Yes, nail fall down. That means what? Conduction heat transfer takes place. Okay, fine. Now, some factors they're going to affect on the conduction heat transfer. Yes, dear students, when it comes to conduction heat transfer, there are some factors they're going to affect on the conduction heat transfer. So, what is the equation for conduction heat transfer, which is given by a scientist, that is Joseph Fourier? What is that equation? Q is equal to minus K into dt by dx. Okay, fine. So now in this temperature gradient, what is temperature gradient, dear students? Initially, as I told, I will take in a metal plate. I am going to supply heat at this end. Heat is moving in this direction. It is having an area. That plate having a thermal conductivity also. Then one end of the high temperature region, I will mark here as a temperature T1. Then low temperature region, I will mark it as a T2. Then it is having a thickness. That thickness of the plate I will represent it as a dx. Then change in temperature to the thickness of the metal plate is nothing but what? Temperature gradient. If more temperature gradient, then more heat transfer is going to take place, because Q is equal to, you can see now it is directly proportional here now, dt by dx. Hence, if more temperature gradient, hence we can get more rate of heat transfer, dear students. One thing, material properties. If you are taking this as a metal plate, right, material, so that metal or material play a very important role, because you can take up, so it materials, it is going to have some properties. Thermal conductivity, one of the important here now. If aluminum, it is having different thermal conductivity. If you take copper, it is different thermal conductivity. If you are taking steel plate, it is having different thermal conductivity. Hence, the properties of material also play a very important role in the conduction heat transfer, dear students. Okay, so that is nothing but what? Material properties, we can say. Then area. So that area also play a very important role in the conduction heat transfer. If more area, then more amount of heat is going to transfer. If area is less amount of heat is going to transfer. That because so, because area is directly proportional to Q, because it's a product here, right? If area increases, what happens? The conduction rate of heat transfer is going to increase. That's also one of the important thing. Then thickness. If heat is moving in this direction, right? If thickness is more, if the thickness of the plate is more, then what happens? Rate of heat transfer is going to decrease. So that is the one of the important thing here, dear students. Okay, I explained you how to draw the thermal circuit for the particular case. Okay, dear students, if you like my videos, please do subscribe, comment and support me. Thank you. We'll continue next class.